will continue on where we left off earlier with some advanced file processing. I don't know why I said where we left off earlier because we finished the earlier chapter, and now we're moving on to what's covered by Chapter 5 in our textbook, some of the stuff in Chapter 5. But before I get started with the Chapter 5 stuff, I will go back and show you join, since I failed in the previous podcast. The main problem with join is that it wanted the files to be sorted. So I sorted my files, join 1, join 2. It wanted to be sorted, the files to be sorted in order of the key. So here's the key, if you will. That was air quotes for those of you who missed that. Here's the key, the field we're going to be joining them on. So it wanted the files to be sorted, so I sorted them. Now, let's see. Here's the syntax. Join -1, 2 says which field in the first file to sort on. So this is field 2, the numbers. -2, 2, same thing. Which field in the second file to sort on. And then this output statement tells what you want to print. So I wanted to print file 1, field 1, file 2, field 2, and then we need 2 files. So file 1, file 2. So this should print out each name and then the associated food or drink product with that name. So that does that. So that was pretty exciting, right? So I wanted to get that out of the way so I didn't feel like a failure anymore. So now I feel better about myself. My self-esteem is up a little bit. I can go ahead and keep going with the newer stuff. So newer stuff, Chapter 5, what do we got in here? We're going to talk about some advanced file processing skills, some extra stuff we want to do. Table 5.1 and 5.2 show some commands for selecting data. 5.2 shows some commands for manipulating data. But the first thing we're going to talk about is the pipe character. You've already been seeing me use the pipe character repeatedly throughout this course. The pipe character essentially ties 2 commands together. When you put a command, cat sort, cat file for sorting. When you put 2 commands together with a pipe, it takes the output of one command and sends that into the input of the other command. So conceptually, instead of the output of cat, right, cat normally sends it to the screen, which is standard out. I'm now saying, hey, I want you to send that standard out into this command. So that's one of the fantastic things that I like a lot about Unix and Linux. You have tons of simple commands that you can combine together to do very powerful things. So instead of having one very huge command that does a bunch of stuff that most of the time you don't need, you just take a bunch of small commands and put them together. So that was one example of pipe. So let's say, oh, we got that list and these sorted. I want to know how many items I need to buy. So first thing I want to do is get the unique list. Remember I showed you guys how we could do that. We piped it into unique. Unique. This is going to give us a unique list of items. I could then pipe that into word count, which we'll learn about in a little while. Word count, yeah, that's on our list. I could pipe that into word count. Word count normally tells us 3 things, but I want to know how many lines are in the file, right? So that tells me I have 9 items for shopping. I took 4 simple commands and put them together to find out how many items I had in the file. So that's just an example of that. So that's really all I got to say about pipe. Pipe takes the standard output of one command and puts it in the input of the other command, and it's very useful in combining things together. The next command we're going to look at is the grep command. It can be used to search for certain patterns in files. It can be used with certain options to make it do other things. So let's say I wanted to look for my user ID in the password file. In the password file, I could do this, and it will pull out the line for my password entry. And I have 2 because I created some new user IDs for the test. So there's my 2 files. I can combine that with a other command if I wanted to get other things out. So I can use the pipe command to take the output of that command and send that to the cut command, to give me just the username. I just want field 1. Delimiter is a colon. There, I got just the usernames, right? So that's an example of just the most basic usage of grep. I put a full name in there. You can also do patterns in there. The search pattern. So I did RBE0000. Let's say I wanted to find. Let's think of a good example. Let's say I wanted to find. I need a new file. Let's look at the password file. Let's say I wanted to find anybody who had a home directory. Nah, I don't want to look for. Yeah. Well, let's just do. I was trying to avoid displaying usernames, but you can do a ls-home/home and see all the usernames if you want. So whatever, it doesn't matter. So let's say I want to find any usernames that meet our pattern of usernames, which is 3 letters followed by 3 numbers. I can use a regular expression to do that. And a regular expression, let me do that, is if I do something like this. Man, it's being real unreliable and intermittent today. See if it eventually comes back. Alright, so this essentially says I want a character that's A to Z, a character that's A to Z, a character that's A to Z, a character that's 0 to 9, 0 to 9, 0 to 9, 0 to 9. So that's going to look for anything that matches that pattern. So do that. These files all match that pattern. So you may be thinking, well, why do we get all these extra ones? Well, if it matches the pattern, it matches the pattern. If you want to be more precise, then you need to put a more precise pattern. If I was just looking for the regular user IDs and not the ones I created for us to use for our test, if I was just looking for those, I can put a colon at the end of my string, and now it's going to look for just the colons. So you need to be as precise as you can to get what you were looking for. So that was grep. Another thing you can do with grep is, by default, grep is case sensitive. So if I'm looking for some reason, I thought I was looking for capital RBE, it's not going to find it, right? Because there is no capital RBE in there. A option I can give grep is -I. I use this all the time, grep -I, meaning, hey, only show me, or actually match without regard to case. So in this case, it should find my 2 lines, which it did find, because I said ignore case, -I, ignore case. Another one I use a lot, say I wanted to find all of the user IDs in the etc password file that were not regular user IDs, right? If we remember, this first command without the colon showed me all of our regular user IDs I created, right? Say I want to know everything that does not match that. So if you do a grep -v, that shows you things that do not match. So if I do grep -v, that's going to show me all the other user accounts in the system. So grep -v will display lines that do not contain the search pattern. Another example of that would be if I do my, that's not a very good example. Say I wanted to look for users that don't have bash as their shell. This shows me all user accounts that don't have bash as the shell. You know, if I want to see all the user accounts that do have bash as the shell, I take the V out. Show me all the user accounts that do have bash as a shell. You can use a -L to just show the file names. So if I was looking for bin bash in a certain directory, I could say, hey, show me everything that has bin bash in it in the etc directory. But I don't want to actually see the matches. Let's go ahead and do it with the matches. That shows you all the matches. say I don't actually want to see the matches. I just want to see the file names. -L. Just show me the file names. And that error stuff, messing up my picture. I don't want to see the errors. Send the errors to devnull. Devnull is a trash can. And there I just have the files that I want to see that have the words bin bash in there. So if for some reason you wanted to do the opposite, you want to see files that don't have bin bash, you can do -V, I think. I've never tried to combine these two before. Yeah, so that shows you all the files that didn't match. Another thing you can want to know is you can say, hey, I don't really care how many. I don't really care to see it. I just want to know how many there are. -C was supposed to tell me how many matches instead of showing them. Oh, that showed. Yeah, it showed you the number of matches outside. So there's one match there in these files, 16 in the old password file, 1 in libuser. So that's the C. -R. If hey yo Etsy, I want you to look under Etsy and all of Etsy subdirectories. -R will do that. It'll probably take a little longer because you're looking at a much larger set of file systems. And then if you want to know where in the file it is, you can do -N, and it'll put a file number on the line. So here it says, hey, this file, this line number, here's the output. So that's the options for grep. I use grep all the time to do all kinds of stuff, so that's a good command to know. Next we have unique, which you've already talked about. Unique. So remember, the thing to remember about unique is the file must be sorted first before you can do the unique. So if we go back and look at our file for sorting, right? It's not sorted, so if we unique that, it's not going to really do anything for us. So if we sort file for sorting and then unique it, then it's going to get rid of the stuff. You can do a unique -U to find out lines that are not duplicated, right? So that shows us lines that don't have more than one copy. I'm not real sure why that would be useful. I've never ran into a need for that. -D does the kind of the opposite of just showing the unduplicated line. It shows the duplicated lines, but not the ones that aren't duplicated. So this is how you can find out which ones have more than one copy. Again, not sure why you do that. -I will ignore case. So if we go into our file for sorting, this is going to be funny. It's not going to work right, I don't think. If we go into our file for sorting and do coffee, we do try this unique -I. Supposedly it's going to ignore case. Hey, and it did. That's cool. I didn't think that was going to work. I thought sort was going to not sort it right because capital letters sometimes sort differently than lowercase letters. But it still got sorted by coffee. So that's good. I wasn't expecting that. And that's about the interesting commands for unique. Next command is com. It can show you things that it can identify duplicate commands, but it won't delete them. And it works with 2 files rather than 1. So it locates identical lines within 2 identically sorted files. So the files have to be sorted. So that shows you, that can show you files that are similar sorted files. So let's see. I don't have any files for that right now. I never use com, so I'm going to skip over com. I'm not really interested in com. You can read about com, and you'll probably get to do it in the hands-on exercises. It's not very exciting to me. Diff, on the other hand, I do find diff to be very interesting. That shows you where files are different. So if I had 2 files that are supposed to be similar, so let me make up some files. Say I told you guys to create a particular output file, and it had, answers 1, answer 2, answer 3, 3, answer 4, answer 5. And let's copy that, make that div file too. So say I had sorry, I'm thinking about what I'm trying to do. Say I had a file that had the different answers you guys were supposed to have in there, right? This is your answer file. My other file is a key, right? So I can use diff to find out which files are different. So there it says, hey, line 1 is supposed to be, one file has answer 1 and one file has answer 3. Line 4, one file has answer 4, the other file has answer 5. So this less than and greater than tells you which file it came from. So less than, pointing that way, that'd be the first file, has answer 1. This says, hey yo, the second file has answer 3. There's some other output things you can do for that. Didn't see the example I wanted. Let's see what -y does. -y looks like it might be more interesting. So yeah, so -y shows the lines side by side and then shows a little character, a pipe character, to note there's something different. So in theory, if I was to create a answer file, I could use a diff command to find out, does your answer file match my file, and where it doesn't match, so I can know how many points you deserve to lose for not doing what I wanted you to do. So next we have the word count command, which I've already used a little bit. Word count by default shows you 3 things. 1, the number of, let's see, the number of, what does it show you? Number of lines, words, and characters. So lines, words, and characters. So Etsy password file, there's 55 lines, 62 words, 3192 characters. You can do a -L to show you just the number of lines, right? 55 lines. You can do a -W to show you just the number of words. You can do a -C to show you just the number of characters. So those are some different things you can do for word count. So that's useful. I wonder if you can use a -D to specify a delimiter. Let's look at that. Because we're getting a word count from, slow again. We're getting a word count from the password file that I would think would be much higher than it actually ended up being. This is getting ridiculous. Maybe I should play some more music for you guys. No? Ugh. Finally. Let's see. Words. No. It doesn't look like you can specify a delimiter. So, yeah, that counts a word based on space, white space characters. So, if there's a space in between the words, then that'll count as an individual word. So that's word count. Pretty cool. Use it a lot. Sed can do some good things for you. It can help you transform your text. So if you had some text you wanted to change around, you can use sed for that. So there's some hands-on projects that go through that. I use sed some, but not a lot. So it's something like, let's let's say I want to substitute all the colons in the Etsy password file. I want to make pipes. I'll do that globally. So let's see what happens. Yeah, I can put that in single quotes. So there. Let's let's look at what happened here. So basically said, hey, I want you to substitute all the colons for pipes. I want you to do that globally. Because if I didn't do the G, it's going to, let me take a step back. From the Etsy password file, so if you remember the Etsy password file, it was colon delimited. Now it's pipe delimited in my output. If I didn't do the G, it's only going to do the first occurrence. So there, it changed the first one, but not the second one. So that's sed's useful for that. By default, it outputs to the standard output. So if you want to save your output, you need to make a output file. Pipe password. And then I could look at that. So there's my pipe password I created for whatever reason I might want to do that. So that's that. It also can, the book says, translate characters. So if you want to translate from like uppercase to lowercase, stuff like that, you can do that. So I think you can do that. Let's try that. So you can do something like this. TR. I want to do lowercase. Lowercase. What the heck? To uppercase. Try that. No, didn't like that. Oh, because there's this. What the? Oh, wait, I skipped ahead. I went from sed to the tr command. There's a way you can translate in sed. That's probably called substitute. Let's try that. And let's not write it to a file. I got a head look in the book. So you can substitute. That didn't work out like I expected. So you can substitute. That's pretty ugly, actually. That's funny. So what it did was everything that matched a lowercase letter, it changed to this string, which isn't exactly what I wanted. But oh well. I'm not really worried about that because I got ahead of what I wanted to look at anyway. So sed can do a lot of things. Substitutes and other stuff. I usually use it for substituting, and I don't use sed a lot. So when I do use it, I usually have to look up the syntax and spend a little time figuring out what I want to do. TR can translate commands. So translate characters. So let's try this. See if this works as expected. I think this might do what I want. So basically it says any lowercase, make uppercase. Hopefully this will work. Yeah, so translate did that. Convert uppercase to lowercase or whatever. That's the example I gave in the book. Example said, hey, replace the C with nothing. So if we wanted to get rid of the colons, we could say, hey, I want to translate the colon into nothing. Yeah, so I got rid of the colon. So you can do other stuff. Say I wanted to translate the colons. Oh, check this out. I'll do that, and then I will pipe that into another tr command that says, hey, yo, I want these slashes to become the other way slashes. Hey, that's going to be weird, right? And now I have the slashes going the wrong way. That's the most ridiculous thing I've ever seen in my whole entire life. Who's ever saw such ridiculous slashes? But anyway, that's translate can do. PR command prints the specified files in standard output in paginated form. I don't think I've ever used a PR command. See what happens. Wow, that was cool. I don't know what was so awesome about that. Oh, it put some page. Oh, check that out. It put a header and a file name and a page number. Okay. So there might be some use for that. I don't know what it is. I'm not worried about that right now. All right, the next part of the book says designing a new file processing application. I would encourage you to read through that, especially if I ended up assigning any projects that need that information, but I'm not going to go through that. That's more about developing a methodology for designing your application and that kind of stuff. And then there's a part about writing a shell script to implement the application. We're not really probably ready for that yet. So that's going to be coming up in a module later on where we'll be writing spreadsheets, not spreadsheets, writing shell scripts. So we'll worry about some of that stuff when we get there. Then running a shell script, I went over that in the previous podcast where you can run the script, sh script 1 will run the script, or you can, do chmod as we did, u plus x script 1, and then you can run the command /script1 to run the command. So that was that. Nothing very exciting or new there. And that pretty much takes care of it for this podcast.